John Linneball from John Linneball Tutoring, and this is my video, Last Minute SAT Tips 10-1-16. This is intended for people to use before the October 1st, 2016 administration of the SAT, but of course it'll be good for future administrations of the SAT as well. So this is part one, Math, Factoring, and the Quadratic Formula. Factoring is probably the first way that you've learned how to solve a quadratic equation, an equation where the variable x has its highest power as 2. So it's usually best to get it into the form ax squared plus bx plus c equals 0, where a, b, and c are constants. That means numbers that don't change. So then you need to find two numbers that add up to whatever b is and are factors of c, or multiply to c. So let's say we have the equation x squared plus 6x equals minus 9. So first thing we need to do is convert that into a form like ax squared plus bx plus c equals 0. So we just add 9 to each side and end up with x squared plus 6x plus 9 equals 0. So, all right, what two numbers add up to 6 and multiply to 9? Hey, 3 and 3. So 3 plus 3 is 6. 3 times 3 is 9. So x plus 3 times x plus 3 equals 0. So the solutions are both negative 3. In other words, there's only really one solution, and it's negative 3. We can check using the FOIL method, first, outer, inner, last, which is just applying the distributive law to binomials. So first, x squared equals x squared. What I mean is x times x equals x squared. Then x times 3, the outer ones, is 3x. The inner ones is 3 times x, so that's another 3x. Then 3 times 3 equals 9. So you end up with x squared plus 6x plus 9 is equal to 0. So that's how to do factoring. The quadratic formula is a great way to solve any quadratic equation, and that comes in handy when a quadratic equation cannot be factored and completing the square won't work. So a hint that you will need to use the quadratic formula on the SAT, or the ACT for that matter, is if the answer choices all have radicals, that is, these nifty square root signs in them. So this b squared minus 4ac is called the discriminant. If it's positive, that means there are two real number roots, or solutions. If it's 0, the two roots are real and the same. So just like this previous one, x squared plus 6x plus 9 equals 0, that would be with a discriminant of 0. And if the discriminant is negative, the two roots are imaginary. Now here's an example I just made up a little while ago. 3x squared plus 2x plus 14 equals 0. So there, a is going to be equal to 3, b is going to be equal to 2, c is going to be equal to 14. Now, I don't know of any numbers that add up to 2 and multiply through to 14, so we're going to have to see what happens here. Well, first of all, b is 2, so we're going to have negative b plus or minus b squared. So that's 2 squared. Minus 4ac, well, a is equal to 3 and c is equal to 14, so that's minus 4 times 3 times 14. So you can see I laid it out here as negative 2 plus or minus the square root. This little radical sign should be over this whole thing. So it's going to be 4 times 3 times 14, and then this whole part is going to be this part over 2 times a. Well, a is 3, so 2 times 3 is 6. So we have negative 2 plus or minus the square root of 4 times 3 times 14 over 6, which is negative 2 plus or minus the square root of negative 164 over 6, which is equal to negative 2 plus or minus 2i times the square root of 41. Now, where did the square root of 41 come from? I just factored out 4 and 41. 4 times 41 is 64. The square root of 4 is 2, so that just becomes 2. And then I is the square root of negative 1, so you end up with 2i times square root of 41, which we can't simplify, over 6. Now, 6 is divisible by 2. Negative 2 is divisible by 2. 2 is obviously divisible by 2, so we divide through by 2, and we end up with negative 1 plus or minus I times the square root of 41 over 3. So -1 plus or minus the square root of 41 times I over 3 is approximately equal to -7.40 times I and 5.40 times I, where I is the imaginary number. So this is probably a much uglier and more complex problem than you would run across on the SAT, but you might. So it's a really good idea to know the quadratic formula, because that way, if you're having trouble, if you see multiple choice with radical signs in it, you will know, ooh, I better know the quadratic formula. And you'll have to memorize it now because it is not given in the math facts section at the beginning of every SAT math section. So you will just have to know it. Okay, hope this helps. And please take a look at my next math video, which will be recorded in about a minute. Talk to you later, guys.